Watch the complete playlist on the app Pions. Download the app now.
Question number 1 says 10 to the power 20 electrons, each having a charge of this, passes from a point A towards point B in 0.1 second. What is the current in ampere? So first of all, let's first write here, this is our any point A and this is our any point B over here, correct? So from A to B, how many number of electrons? Let me write here n, which is equals to 10 to the power 20 electrons are going. And what is the charge on each electron? So one electron has a charge of 1.6 into 10 raised to minus 19 coulombs, correct? This is our charge on one electron. And they are going from A to B in what time? The time here is 0.1 second, correct? Now the current I will be equals to charge flowing from one end of the wire to another end in a given time. So current is defined as charge flowing per unit time. And how much charge is flowing here? That we have to find. So from first chapter we already know that charge is nothing but number of electrons. So here for the current we can say number of electrons flowing in a given time t. Are we given with all these values? Yes. Let's plug it here. So n is nothing but 10 to the power 20. E, the charge of an electron, is 1.6 into 10 raised to minus 19. Time t here is 0.1 seconds, correct? So here this will give us 1.6 into 10 to the power 20 minus 10 to the power minus 19. It will give you 10 to the power 1, correct? So power will be 1 whole divided by 0.1. Let's remove this point with this point. So we left with 16 into 10, okay? Or you can say 160 amperes. 160 ampere is the amount of current which is flowing from A to B. Done. Now current is flowing from B to A. Be very careful here. The direction of current is from B to A and the charges, the electrons are flowing from A to B. So let me be very clear here. The current flows, in case they ask you the direction. So current flows from B to A, okay, and electrons move from A to B. Done. This is the direction. Clear? This was our first problem. Let's move to question number 2. Question number 2 says a 10 volt battery of negligible internal resistance. So there is a battery over here, 10 volt, okay, of negligible internal resistance. So we are assuming that internal resistance is 0. Is connected across a 200 volt battery over here and a resistance of 38 ohm as shown in the figure. Find the value of the current in circuit. Clear? So we know from Ohm's law, voltage V is equals to IR, correct? So current I must be equals to amount of voltage in the circuit upon the resistance in the circuit. The total voltage upon total resistance, right? That's the current. So to find the value of current, you have to first find what is the voltage across this whole circuit. Because there are two batteries, okay? So for the minute to figure out the voltage, okay, let's imagine this like this. So this is our 10 volt over here. This is our 10 volt battery. Let's ignore this 38 ohm for the time being and just connect. Positive is connected to positive of this 200. Like this it is, correct? So if you ignore this resistance, our 10 volt battery is connected to 200 with a positive terminal to the positive terminal. Be very careful, okay? So in positive to positive, if it is connected in the same loop, whole loop, okay, if the loop is changing, then the things will be different. Be very careful. But if it is in the same loop, if they are connected with positive, then you have to subtract it. Okay, negative with negative, it will be subtraction. So when will it be added? If you have a positive, negative connected with positive, negative, right? So this negative is connected to the positive terminal, then in that case we add the voltages, right? If they are in the same loop, listen very carefully. Okay, if they are in different loops, then you have to be little careful. Okay, you have to follow Kirchoff's rule. What will be that? We will see as we will move ahead. So here we have only one single loop and these are the two batteries with positive connected to positive. Now the question is, sir, we have to subtract this 10 volt with 200 volt or we have to subtract 200 volt with 10 volt. Okay, that's your choice here completely. If you want a positive result, okay, so positive result here will be after subtracting 200 volt to minus 10 volt, because obvious it is. that if the battery is higher, the current will be larger, going from 200 volts. So by sign convention also we will take 200 minus 10. That is the effective voltage in this whole circuit. And what is the effective resistance in this whole circuit? 38. So 200 minus 10, 0, 10 minus 1 is 9 and 190 upon 38, correct? So 19 ones are 19 twos are, correct? So that will be the 10 by 2 is nothing but 5 amps. So 5 ampere is the current which is flowing in this whole circuit. Let's move to question number 3. Question number 3 says, find the resistivity of a conductor in which the current density. So current density, let me remind you once again, it is denoted by J, and that was nothing but I by A. Current per unit area is known as current density, right? And what is the value here given as 2.5 ampere per meter square, right? This is our current density, which is current flowing in a given cross-sectional area, that is J. And if the current is flowing through a given uniform wire, okay, then the current density remains constant, okay. Next is found to exist when the electric field E is how much? 15 volts per meter. So both the units are proper. Volts per meter is also a unit of electric field, and Newton per coulomb is also a unit of electric field. So both are fine. So J is this and E is this. Okay. Question is asking find the resistivity. You have to find a rho. Question is asking find the value of rho. Clear? So let's try to simplify it using these two. Okay, let's simplify. First find the value of in terms of rho. Clear? So we know that J equal to, okay, that we have another relation also. J equals to sigma E, if you remember. Where J is current density, sigma is conductivity, and E is electric field. So if I take this sigma on the left hand side, it will be 1 over sigma, that is J, and that will be equals to E. And 1 over sigma is nothing but rho. So rho into J equals to E, if you are not familiar with this expression. Let me repeat again here. J, let me write here J, where J is current density from third chapter, current density, which is current per unit area. Sigma is conductivity. Okay, sir, which topic it is? It is from Ohm's law. Okay, it is the extended, okay, version of Ohm's law. E is electric field. Electric field. Now, sir, sigma is conductivity, so resistivity. This is inverse of conductivity is resistivity. Clear? So let's find resistivity now. We got the relation. So resistivity rho will be equals to E upon J. Are we given with the value of E? Yes, 15. And what's the value of J? 2.5. All they are in the standard units? Yes. Let's remove this point. You get here 0, 5 5s and 5 30s and 5 6. So resistivity is 6. Now what's the value of our unit of resistivity? Resistance we know R equals to rho L by A, okay, and resistance is ohm, so ohm and meter. Ohm meter is the resistance, okay, resistivity unit ohm meter, or you can also write it as Siemens, okay, Siemens is also fine. So ohm meter is also our resistivity. Done. Let's move to our question number 4. So our question number 4 says calculate the electrical conductivity. So they are asking electrical conductivity. What is conductivity? Sigma of a material of a conductor of length L is equals to 3 meters here given. Area of cross section A is equals to 0.02 millimeter square. So here only I am converting this millimeter square into meter square. So 0.02 into 10 to the power how much? It will be -6 meter square. Sir, how you got that? Millimeter, 1 millimeter is 10 to the power -3, correct? So if 1 millimeter is 10 to the power -3, okay, meter square will be meter. So meter square means squaring both the sides, it will be 1 millimeter square will be 10 to the power -6 meter square, correct? So this will be our conversion. So let me remove this conversion from here and let's continue with the question. So calculate the electrical conductivity of a material of conductor length is given here. area of cross section is given here and resistance R is given here with 2 ohm. Clear? That is in standard unit. So first of all, we know that conductivity is nothing but opposite of resistivity, correct? So what is our resistance formula in terms of resistivity? Rho L by A, correct? So rho will be equals to how much? It will be R into A whole divided by L. And since we don't have to find the resistivity, we have to find the conductivity. So sigma will be equals to 1 upon rho. So which means you have to reciprocate on the right hand side R into A. Now what is L? L is nothing but 3. R 2 ohms, area 0.02 into 10 to the power minus 6. Let's take this 10 to the power minus 6 on the numerator, and this will be 3 upon 2 into 0.02 and 10 to the power 6 goes up, correct? If you remove this decimal also, it will be into 100. So this will be 3 by 4 into 10 to the power 8, correct? This is our, okay, conductivity, sigma. Clear it is? So that, what's the unit of conductivity? Ohm inverse, meter inverse, okay? And you can also call it as, okay, ohm inverse and meter inverse, okay, that's fine. That is our sigma. So this is our answer to this particular question. Let's move to question number 5. Question number 5 says a wire of, question number 5 says a wire of 10 ohm resistance. So R is equals to 10 ohm, let's write here 10 ohm, is stretched into thrice of its original length. Be very careful, it is stretched to thrice of its original length. So let's say its original, okay, original length is L. So what will be its new length? Its new length will be L dash, which will be 3 times the original length, right? Let's read the question once again. A wire whose initial resistance is 10 ohm is stretched to 3 times its original length. What will be its new resistivity and new resistance? Let me be very clear here, the new resistivity will not change. Why? Because the material with which the wire is made up of, that is not changing. And resistivity only depends on the type of material and temperature. So the new resistivity will remain same. It will remain same. So, sir, what about the new resistance? Now, the new resistance will change. Of course, it will change because the length is changing and because the area is also changing. We have learnt in class 11th that if you take any wire or any solid material and if you apply some force on this wire, then what will happen? Its length might increase, okay, in the chapter elasticity, okay, solids. Its length will increase, but when its length will increase, even its diameter will also decrease. So this diameter, when your L dash is our new length, which is 3 times the original length, and this is our previous length, with the area here or area of cross section or radius is R, so area of cross section is A, the new area will be smaller than the previous area. But how much it will be smaller, that we will see within a minute. So this is very, very important concept that when you are stretching a wire, its volume changes. Okay, volume remains constant, only the area and the length changes. So let's start with the second one. The overall volume of the wire initially will be equals to the volume final, V dash. So V is the volume of this wire and that must be equal to V dash here. Clear? So V equal to V dash. Now why V equal to V dash? Because the density remains same, right? So density and mass not changing for this particular, so the volume also remains same. Now what's the volume of the first wire? It will be area into length. Sir, from where you got this formula? You can use anything. You can assume this as pi r square h. Pi r square h is, okay, the cylindrical. So pi r square is area of cross section and h, which is the length of the wire, you can assume. Or even if you are taking cuboid, okay, length into breadth is the area of the base and height into height is volume. So area into length is always volume, okay. And this will give us here new area A dash into the new length L dash. I hope this is clear. Now, what is our new length? So new length here is nothing but 3 times the previous length, correct? So L cancels with L, and you left with A upon 3. If you divide the area, 1/3 of the area is the new area. Let me keep it in a box because we will be about to use it. Correct? So the new length becomes 3 times the previous length and the new area becomes 1/3 of the previous one. Okay? And that is obvious because the area decreases when you stretch it. Now what will be the new resistance? Let's call it as R dash. That will be equals to rho. Why sir rho? Because as I said in the previous case, the resistivity doesn't change. So what will be the new length? L dash. And what will be the new area? A dash. Let's substitute the values. So it will be rho. What is the new length? 3 times L. What's the new area? A upon 3. So that 3 will go on the top. Let me repeat again. This A dash is A by 3 and 3 goes on the top. So this will be equals to 9 rho L upon A. That is our R dash. Now what is rho L by A? So rho L by A was the resistance of the previous case. Clear? And what is that previous case? Look here, it is 10 ohm. Rho L by A is the resistance in the first case, in the initial case, because length was L and area was A. So that was the resistance in initial part. So here we can substitute 9 into 10. So R dash will be equals to 9 into 10, that is 90 ohms. Done. This is the new resistance, okay, of the wire after stretching it 3 times. Let's see our next question, question number 6. Question number 6 says a wire has a resistance of 16 ohms. So let's write R, that is equals to 16 ohms. It is melted and drawn into a wire of half of its length. So let's say the length when this was R was rho L by A. L was the length and area is A. So if it is melted and drawn into a new of half of its length, let me first draw our initial. Roughly speaking, it looks like this, with the length of this wire as L and area of cross section was A. Now we are melting it and making it into half of its original length. So half means it will look like somewhat this. So as you can see, now the area of cross section increased. Let's call it as A dash and the length became L by 2. Clear? So melted and drawn into a wire of half of its length. Calculate the resistance of the new wire and what is the percentage change in its resistance. So we have to find two things. One is percentage change and one is new resistance. Correct? So to figure out the new resistance, okay, our new resistance before we find, let's figure out what is our A dash. So as we know that when it is melted and recasted into a new wire, its volume will not change. So volume of the previous wire will be equals to the volume of the new wire. And what's the volume of the previous wire? Sir, area into length of the previous one. And that must be equals to the new area into the new length. That is L by 2. Correct? So L and L cancels both the sides. 2 times area, that will be equals to the new area. As you can see, the mathematically it is saying that the new area will become double of the previous area, and that is obvious that when you are decreasing the length, the area gets increased, and when you are increasing the length, the area gets decreased, and that is you can see from this expression also. Now we got our new area. So what will be our new resistance? Sir, our new resistance will be R dash and that will be rho. Rho will not change. Why? Because it depends only on the material and the temperature. So here nothing is changing. So rho, length L, L will become L by 2 and new area will become A dash. Correct? So what is our rho L upon 2? This 2 I am writing here. And what is our A dash? Sir, A dash is twice of A. Correct? So this will become 1/4 of rho L by A. Now what is rho L by A? Look here, it is 16 ohm. Rho L by A is 16 ohm. So this will be 16 upon 4, that is 4 ohm. So what is our previous resistance of this wire? 16 ohms. What is our new resistance of this wire? 4 ohms. If this is our previous resistance and this is our new resistance, what is our change in resistance? Change in resistance is delta R, that is previous one and new one, okay, previous one minus new one. 1 second. So previous one minus the new one, or we can say the larger value minus the smaller value. Okay, not necessary always previous and new. So we will always subtract higher value to lower, so that we can keep the percentages in positive value. Okay, so change in resistance is simply 16 minus 4. 16 minus 4 is 12. Clear? And what is our percentage change? Now this we have learnt in class 6th or 7th standard, that percentage change of anything is change in that value upon the original value into 100. No matter resistance, even if they ask you anything, percentage change of anything, okay, then change in that anything upon original anything into 100. That's our percentage. Okay, this is there in 7th standard. So if you have any confusion, you can go through that once again from 7th standard or 8th standard book. Okay, delta R here in this particular problem is 12. R here is nothing but 16 into 100. Let's cancel out 4 4s are 4 25s and 4 3s. So how much percentage change? 75% change in resistance. I hope this is clear. And let's move to question number 7. A given copper wire is stretched to reduce its diameter to half of its previous value. What would be its new resistance? Okay. So let's say the resistance R of initial value of this copper wire was rho L by A. Correct? So being specific here, area of cross section, since it is circular, it will be rho L by pi R square. Correct? Because area of cross section of a wire is circular, pi R square it will be. Now they are saying they are reducing its diameter. So let's convert this formula in terms of diameter only. So what will be your diameter here? Rho L upon pi, and R is what? Sir, R is d by 2. So it will be d by 2 whole square. So this will be how much? 4. From where we got this 4? D by 2 whole square will be d square by 4, right? Or let me write it in one more step so that all of you can understand it better. Rho L by pi d square by 4, right? This 4 will go in the numerator. So resistance here, initial resistance is 4 rho L by pi d square. Now this is our initial resistance, right? Now they are saying a given copper wire is stretched to reduce its diameter to half of its value. So now the new wire, let's say this is the new wire, okay, or the diameter is reducing. So diameter is reducing, which means you are stretching it. So here it is. Now what is the new diameter? Let's say d dash. And what will be d dash? So it will be equals to d by 2. Correct? Now volume, the previous volume must be equal to the new volume. Correct? So what's the previous volume? Pi r square into length L. What is pi r square? The pi r square is our area. So area into length. Okay. Now what is r? R in this case is d by 2. So d by 2 whole square into L. Here it will be pi into, what is the new diameter? It will be d by 2. Okay. So new diameter is d dash, which is equal to d by 2. So this will be d by 2 whole divided by 2 whole square into, what is the new length? L dash. Correct? Let me repeat this whole expression once again. Our volume is area into length. So area is pi into previous diameter upon 2 whole square. Now new diameter upon 2 whole square. New diameter upon 2 will give you radius. So that's why we divided it with twice. Okay. So let's simplify. Pi will cancel with pi. And what will be our this thing? D square by 4 into L. And this will be d square upon 4 and 4. 16 into L dash. So let's take this, okay, d square cancels with that, and 4L will be our new length. Okay, L dash will be 4 times. When you will cross multiply the 16 on the left hand side, that will cancel out with 4. 16 upon 4 is 4, correct? So this is our new length. If this is our new length, L dash, okay, then can we find our new resistance? Yes, R dash, that will be equals to rho new length L dash upon area pi R dash whole square, correct? So I am not using this expression. Let me use our this new expression which is written over here, correct, on the left hand side. So that will be r dash equal to 4 times rho L dash upon pi d dash whole square. Directly we can plug it here. So this will give us 4 times rho L dash. What is L dash? 4L upon pi. What is d dash? D by 2 whole square. Correct? I hope this is clear. So this will give us here as how much? 4 and 2 4, 16. Let's write here as 16 rho L upon pi d square by 4. I take this 4 on the top, so it will be 16 into 4 rho L upon pi d square, correct? I have not multiplied this 4 with 16. Why? I'll explain now. 4 rho L by pi d square, that is nothing but, look at the left hand side, this is our R. So what is our new resistance? Our new resistance is 16 times the previous resistance. Done. This is our question number 7. Let's move ahead with our next one. Let's see question number 8. Question number 8 says a metallic wire of length 1 meter is stretched to double its length. Calculate the ratio of its initial and final resistance, assuming that there is no change in the density on stretching. So density is not changing, which means mass is not changing and the volume is not changing, right? Okay, great. So let's start with this, a metallic wire here of length 1 meter. So let's say this is the wire of length 1 meter and it is stretched to double its length. So if you are stretching it to double its length, okay, which means the diameter reduces or the radii reduces. What is the length here? 2 meter, correct? Okay. Now, what is our initial resistance? Our initial resistance was R, which is equals to rho L by A. So, what will be your R dash? Our R dash will be equals to rho L dash by A dash. But we have to find now A dash. So, volume of this one will be equals to volume of this second one, correct? Or let's put it as V and V dash only. Now, V is nothing but area into length of the first one will be equals to area into length of the second one. And length of the second one is twice, correct, of length of first one, double it is as per the question. So, L cancels with L and A by 2, that will be equal to A dash. Let's substitute here. So, R dash will be equals to rho L dash. What is L dash? It is twice of L, correct, whole divided by, what is our A dash? A by 2. Now, let's take this 2 on the top and R dash will be equal to 4 times rho L by A. And what is rho L by A? That is our previous resistance. So, R dash will be 4R. Now, they are saying find the ratio of initial and final resistance. So, let's take it as 1 by 4 equal to R by R dash, correct? I take R dash on the right hand side, it goes below the R, and 4 on the left hand side. So, we can say initial to final resistance ratio is 1:4. Done. This is our answer. Clear with this? Let's move to question number 9. Question 9 says, estimate the average drift speed. Question 9 says, estimate the average drift speed, drift velocity basically, of conduction of electron in a copper wire of cross-sectional area A is equals to 2.5 into 10 to the power minus 7 meters square. This is our area of cross section. Having a current of 2.7 ampere, I will be equal to 2.7 ampere. Assume that the density of conduction of electrons, conduction electron density, okay, number density, be very careful, this is number density, N is equals to, what is number density? Those who don't know, it is number of particles per unit volume. Which particle? Conduction particle. So, here they are conduction electrons and units can help you to understand it better. So, in a given volume, how many electrons are there? 9 into 10 to the power 28. Okay, so that's a meter minus 3. What you have to find here? Drift velocity. So, let me remind you a relation between current and drift velocity. I equals to NEA VD. Okay, this is our formula. Current is NEA VD, where N is the number density, number of particles per unit volume, E is charge of electron, A is the area, and VD drift velocity, and I is current. Now, VD we are looking for. So, drift velocity will be equals to I upon NEA. Now what is our current here? So current here is 2.7. Number density here is 9 into 10 to the power 28. Electronic charge 1.6 into 10 raised to minus 19. Area 2.5 into 10 raised to minus 7. Correct? So I upon NEA, this is our drift velocity VD. So this will give us here as, let's simplify it further. So this will give us 2.7. Let's remove this 2.7 with 1.6, correct? So that it will be without any decimal. So 9 cancels with 27, 3. So let's write it as 3 upon 16 into 2.5. We will multiply that within a minute into 10 to the power. Let's simplify. 28 minus this, let me just keep it 10 to the power 28, and 19 and 7. That will be how much? 9 and 7, 16 and 1, 26 minus 26. 28 minus 26, 2. So this will be 3 upon 16 into 10, 2.5 into 10 to the power 2. Correct? 10 to the power 2, I am taking that with 25 and making this as, let me solve it this side. VD will be equal to 3 upon 16 into 25 into 10. Okay? Now it becomes easy. So 16 into 25, let's solve it here. So 25, 16, 16 into 25. So 5, 6 are 30 and 5 and 3, 8, 2, 6 are 12, 3, 0, 0, 1, 400, correct? So this will be our 3 upon 400, so 4 into 10 to the power 3. So this will be 3 by 4 into 10 to the power minus 3 meter per second. That will be the unit, and you can convert that 3 by 4 into decimals if you want. Okay, I am leaving like that. So this is our drift velocity of the electrons inside this conductor. Clear? Let's move to question number 10. Question 10 says a potential difference, okay, of 6 volt. So voltage here is 6 volt is applied across a conductor having length L equals to 0.12 meter. Calculate the drift velocity VD. You have to find if the electron's mobility. Now let me remind you, mobility is mu, which is 5.6 into 10 to the power minus 6. Clear? So let's, along with this, okay, this is our unit, meter square, okay, volt minus 1, second minus 1. Let me remind you the formula for mobility. Mobility is mu, which is equals to the amount of drift velocity produced in a given, okay, wire or across the electrons upon the unit electric field applied. Let me repeat again, how much electric field you are applying across the wire and how much drift velocity is producing. The ratio of both is called as mobility. In a simple sense, mobility, this word arises from mobile. Mobile means something, a device which can move. So mobile is phone, okay, that the name is not mobile, okay, people call it as mobile, but it's actually mobile phone, a phone which can move. Mobile means move, something which can move is called as mobile or mobility. So mobile phone, a phone which you can carry with yourself, that is called as mobile phone. Okay, so but people skip that phone part, they just simply use mobile. Okay, so that is not actually mobile, that's mobile phone. Okay, same thing here. Mobility is a factor that tells us that in a given wire, how many electrons are free to move, how many free charge carriers are there. So drift velocity VD upon E. What is our VD? We have to find, an electric field not given, correct? So let me just rearrange and see if the data which is given, we can use them to figure out our VD. So mu into electric field. But voltage and length is given, so we can just rewrite this expression as drift velocity will be equals to mu into, from second chapter we know that voltage per unit length is electric field, so V by L. And what is mu? Sir, mu is nothing but 5.6 into 10 raised to minus 6 into voltage, which is 6 given as per the question, and upon length 0.12. Let's remove this point, we got here 10. Let's remove this point, we got here 100. 10 and 100, 1 cancels, 6 2s are 2 5s are done. So what we left with our drift velocity here as 5.6 into 10 raised to minus 6 multiplied with 5, correct? No, sorry, this decimal is gone. So it will be 56 into 5. So 5 6 are 30, 25 and 3 28 into 10 to the power minus 6, correct? So 56 into 5 is 280, so that you can write it as 28 into 10 to the power minus 5 meter per second. That will be the velocity of the electrons moving in this particular conductor. Yes. Okay. Let's move to our question number 11. Question number 11 says a wire of resistance 4 ohm. So there is a wire of resistance 4 ohm. Okay. Let's just draw it in a simple sense. This is our wire of resistance 4 ohm. 4R, sorry, is bent in the form of a circle. So let's take it like this. Still the total resistance of this wire is 4R. What is the effective resistance between the two ends of the, between the ends of the diameter? So let's choose any end of this diameter. Let's say this point our A, and diametrically opposite point here is point B. So we have to find across these two. So if we are taking from these two, we know that half of the length is above this AB and half of the length is below, right? So if half of the length is above and half of the length is below, we can simply say that the upper part or above one will have a resistance of 2R, and the lower one, since it has half of the length, it will be 2R. Sir, how do you know that this must be 2R? Okay, how can I assume that you are saying correct? Because we know that resistance R depends on length, correct? So if you half the length, the resistance becomes half. When you are making it in complete circle, no matter what is the size of the circle, we know that at diametrically opposite points, upper part is a semicircle and lower part is also a semicircle, which means half of the length of the total wire, let it be 10 meter wire, let it be 5 meter wire, let it be 1 meter wire, half part will be up, half part will be down. And if half part will be up, the resistance will also be half. So upper part will have 2R and lower part will have 2R. So this end will be our A, this end is our B. Both are connected in parallel. Okay. So if they are connected in parallel, what will be our R equivalent? So R equivalent will be equals to 1 by R1 plus 1 by R2. So this will give us 2 by 2R, that is 1 by R equivalent, and R equivalent will be equals to 2R by 2, which is R. So the new resistance offered by this whole wire in form of a circle across the two diametrical ends will be R.
Watch the complete playlist on the app Pions. Download the app now.